Okay, so here we're asked to take the region that's been generated by taking a graph of y equals the square root of 8x minus x squared on the interval 1 to 7, revolve it about the x-axis. Okay, so we want to find the surface area, but we want to go a step further. This time we're going to paint this thing. And we want to know how much paint we're going to need if we're going to use a coat that is 1.5 millimeters thick. So what we're going to assume here, since we're told that the thickness of the paint's 1.5 millimeters, we're going to assume that all of these dimensions here are also in millimeters. Okay, also in millimeters. Just, so everything makes sense unit-wise. Okay, so this is something that's actually very, very small. Very, very small. It's only has dimensions from 1 to 7. You can see what it is, if you will. This is a circle, a semicircle, and we're actually slicing off the top. So we're basically taking this very tiny globe, very tiny sphere, and we're cutting off the top and bottom to generate this circular thing. And we're just painting along the outside. We're not painting these anterior edges of the circle, because that would be a more complicated problem, involve more work. We're just looking simply at this situation. Okay, so let's approach this problem here and set it up here. Okay, so first things first, my function I'm going to rewrite as 8x minus x squared to the 1/2. We're going to need to compute y prime. So y prime by the chain rule, we would multiply by the exponent, the outer function. So 1/2 8x minus x squared. Now the negative 1/2 times the derivative of the inside, the 8 minus 2x. Okay, so the 2 once again goes into both of those, so that y prime is 4 minus x on top over that stuff down to the 1/2 or the square root of 8x minus x squared. Okay. And then our surface area will be the integral 2 pi interval 1 to 7 of our function, which is the square root of 8x minus x squared, times the arc length. Oops. The arc length, which would be the square root of 1 plus 4 minus x over square root of 8x minus x squared, and then dx. I'm kind of running a lot over here. We actually just do this. Dx. Okay, and this time I'm going to use technology. Ignoring the pi for the moment, of course. I don't want to include the pi when I do this numerically. But I'm going to go and do technology. Now, what could happen is you could work this one out as well by hand. You can work this one out as well by hand. And it's going to be very similar to the last one. It's going to be very similar to the last one, where eventually this denominator inside the square root will cancel with that thing, and there's going to be something left on top. Okay, so it's going to be very similar to the problem there. It's going to be different, that's all. But we're going to do this numerically, so I'm going to get my 84 calculator out and do the FNN. So it's 2 pi, so I'm going to do 2 times, and then my FNN, integral from 1 to 7. and then putting in my function here. So square root of 8x minus x squared. And I need to get outside of the square root. And then second square root, 1 plus, and then parentheses, 4 minus x divided by the square root of 8x. Oops. 8x minus x squared. Right, that's the square root. Close my parenthesis, and that's all squared. And now I'm ready to work this out. And that gives me an answer of 48 exactly, which tells me that, that worked out pretty well. And so, of course, the real answer would be 48 with the pi attached. So, 48 pi. Then, that's the surface area. That whole surface area needs to be covered in a 1.5 millimeter thick coat of paint. So we take that times the 1.5 millimeters, and we get that we need 72 pi cubic millimeters of paint. Cubic millimeters of paint. Okay. All right. So there's an example. This time again, we used technology to save us some work, and that's something I will allow you to do with some of these. I'm pretty clear in the test how you need to do them. And generally, with surface area, especially with the ones that are a little more complicated, I'm fine using technology to compute that definite integral.